Welcome to another LeetCode problem. So today we are going to solve problem number 973, k closest points to the origin. So what is, if I read the problem description, you are given a points. Points is nothing but a list of your x and y points in your xy plane. So this is basically your x plane, right? Let me change the color here. So this is your x plane and this is your y plane, and then you are given points. So point could be here, here, anywhere, any quarter, right? And then you need to return the k closest points to the origin. So we have to calculate a distance of point to the origin. So this is distance and this is, let's say, distance. So which one is the closest one? So k closest, let's say if k is equals to 2, so out of 4 points you need to find what are the 2 closest points to your origin, which is 0 to 0. But how do I calculate the distance? So they have also given the formula that you have to use Euclidean distance to calculate the distance between the point and then basically your origin. So formula is basically x1 minus x2 square, x1 minus x2 square plus y1 minus y2 square, and then you take square root of everything. But here the origin is 0, so one of the element is always 0. So you have to take only x1 square plus y1 square, and then you have to take square root. So whatever points which is given as part of the array, you have to take the square of each points x and y, and then you take the square root of that. So that is going to be your distance to the origin. Now once you calculate the distance, you have to return the k closest element which is closer to the origin. But in the lesson, in this example, so what is given here? So you are giving two elements, 2 points, 1 3 and -2 and -2, and then k is given as 1. So you have to return only one points which are closest to origin. In this case, if I calculate for 1 and 3, so 1 square if I take is 1, and then 3 square I take is 9. So that is, if I take square root of this, is going to be, let's say, square root of 10. I don't know exactly, but it will be 3.9 something, 3 point something. In this case, even though if it is a negative number, if you take square, that will become positive. So that's going to be 4 plus square of 2 is again 4, and then you have to take square root. So that is going to be 4 plus 4 is 8. So definitely square root of 8 is going to be less than square root of 10, right? So we have to return -2 and -2 as part of your list, because they could be, let's say, if you have 4 points or 5 points and then key is 2 or 3, then there will be multiple entries here. How do we solve this one? One of the ideas, maybe you can calculate the distance and do the sorting. Based on that will be the result. So you can create a list which sorted by the distance, and then you have to return the k element. But you have, for doing the sorting, maybe you'll have to use some sort function or something that will be n log n complexity. But in order to do the better way, you can use heap functionality in Python. So Python, they have called min heap. They don't support max heap, so you can use min heap, and then add element in the min heap, and then when you're popping out, you only pop out the k elements. But you cannot straight away just add the x and y points. You have to add as a distance, so that when you're popping out, so it is always sorted by the distance. So when you're inserting an element in the heap, so you have to insert as a tuple of, let's say, distance and then x and y coordinate. So when popping out, so distance will be used for calculating the minimum information, and then it will return the result. So in this case, let's say square root of 8 will be here. So square root of 8 comma x and y element, which is going to be 2 and 2, so -2 and 2. So and the next is going to be square root of 10, and then that is going to be 1 and 3. So this is going to be my heap, right? So when I pop heap, so pop is going to be, so the heap will pop this element first, and k is only 1, so we'll only pop only one element, and that's it. that will I'll add this information as part of my result. So simple algorithm is, you have to create a heap and store all the distance and their corresponding x and y coordinates. So, and once you're traversing heap, only you have to traverse k times and then pop out all top k elements. So once you pop only top k elements, so let's say in this case it will only pop k is equals to 1, so it will only pop only one element. If k is 2, then it will pop both elements from the queue, and then your heap will be empty, right? So let's look at how we can solve this problem. So if I go to the code, so I have created a heap. Here's just a list here. So I'm going to use, now what I have to do is I have to traverse all the points. So I'm going to traverse into the points, and so either you can take as a list or you can split it as a x and y coordinate directly in the Python. Now I have to calculate the distance before inserting, right? So I have to take square root. I have to take first square, so square of this, square of 2x plus square of y, and I have to take square root of this. So I can use xqrt function in Python that will take square root of sum of these two elements. Now I have to insert into heap, so I can heapify later on, or I can just use heap q top heap push. So I want to push into this particular heap array which I have created here, and what is the element I want to push? I want to push the distance, and then I would push x and y, right? And that's it. Now once I have created my heap, I need to only traverse till k elements. So I can say k in range of k till the time in this range. I need to pop elements, and then pop elements, let's say basically what is going to pop is x and y. You have to pop from heap top uh, heap q dot heap pop, and then say your heap. This is going to be heap q. So it will pop your distance and x and y, because we have, while inserting here, we inserted distance and x and y. So it will pop top distance and x and y. Now what I have to return is, in the result I need to append this particular x and y as a list, and then finally I will be returning my result. So that's the code here, very simple code, not too big and complex. So if I test this, hopefully it will work. So yes, the test cases went well. Let's try to submit it. Okay, so not too bad. 56% beats 66%. That's it for today. Hope you liked the video. Thank you for watching. See you in the next video.